Today we will discuss Michaelson Morley's experiment. The main motive of Michelson's experiment was to study whether which type of material is required for the propagation of light. So let's start with it. Michelson Morley's experiment was developed to measure the speed of light in different directions, and in earlier times it was believed that there must be some medium present on earth so that there is propagation of light, and that medium was supposed to be ether. Ether is any kind of medium which generally have high restoring force, or we can say it has low density. So in this slide we will study the concept of upwind and downwind. As we all know, c is the velocity of light relative to ether and v is the velocity of ether relative to earth. If we are supposing v be the velocity of earth and first case, that is of downwind, that is in the opposite direction, or we can say if we want to write the concept of velocity of light relative to the velocity of earth, then it will be the concept of c minus v, which is considered as upwind. If the velocity of light's direction gets reversed, that is in the case of downwind, in this case relative velocity with respect to earth will be c plus v, which is the case of downwind. In order to understand the concept of Michelson and Morley's experiment, now it's really very interesting to know about the velocity of earth. As we all know, earth generally possesses two types of motion. One is its orbital motion and other one is its spin motion. Earth generally revolves around the sun, and this type of motion is known as orbital motion. But if we will talk about its axial motion, or we can say that earth is spinning about its axis. Since these are two cases, so their rotation time, their rotation distance, their rotation velocity will be different in both the cases, whether we are talking about orbital motion or spin motion. So therefore, in order to measure the round trip for velocity, that is, we have considered the case of upwind, which was c minus v, and c plus v, which was the case of downwind, there must be a time difference to one part. This was the basic setup of Michelson's Morley experiment. Here you can see, first of all, we have monochromatic light source. Then at some distance, there is slit S. Its main purpose here is to collimate the beam, that is to focus the beam towards the partially silvered mirror. Since we all know about the functioning of mirror, the main purpose of mirror is to do reflection. As this is partially silvered mirror, so therefore 50% reflection and 50% refraction will take place in this case. And whenever light will approach towards partially silvered mirror, some of the part will go towards the mirror M1, which will get refracted, and some portion of the light will go towards the mirror M2, which gets reflected. As we all know, it is quite visible from this slide that mirrors M1 and M2 are perpendicular to each other, and the distance from partially silvered mirror A to the mirror M1, its optical path length is L1, and similarly on the other side from A to D, that is mirror M2 from partially silvered mirror, is length L2. So some part which gets reflected from partially silvered mirror after passing through mirror M2 will again suffer reflection, and it will again enter partially silvered mirror, and by crossing the partially silvered mirror, it will enter telescope. Similarly, if we will talk about the mirror M1, that is the part of light which was refracted from partially silvered mirror, will then go towards the mirror M1 and will again suffer a reflection, and on entering partially silvered mirror, one reflection will again be suffered. So in the end it will again enter telescope, which can be seen with the eyepiece E. As we know, there are basically two kind of light rays which are going through in this experiment. So by the concept of interference we can study about it, that these two light rays must interfere with each other with a gap of particular phase difference, or we can say that path difference, so that whatever will be seen through the telescope. And here a compensator is placed so as to adjust the optical length. In this slide we can see the actual Michelson-Morley's experiment, which was performed many years ago at that time. Basically, there are two types of propagation in this experiment. One is parallel and anti-parallel propagation, and otherwise perpendicular propagation. That is, if we will recall the slide, that there were two types of propagation. From A to C it was parallel and anti-parallel propagation. And from A to D it was perpendicular propagation. For parallel propagation we will consider the time of trip to be T1, and for perpendicular propagation the time period would be T2. Since there must be a time difference between these two kind of propagations, so we can easily evaluate times T1 and T2 by using these expressions. Simply what we have done here is, by using the concept of velocity here, that was upwind and downwind velocities. Since length L1 and L2 will be the distance, and in case of downwind C plus V velocity, and in case of upwind C minus V velocity is there, and on solving this we can easily evaluate the expression for time period T1, that is the time for parallel and anti-parallel propagation. Now next comes perpendicular propagation, that is from A to D and its factor. For this, what we have done is 2L2 by under root of C square minus V square, and if we will take common from the denominator, that is C, this will be the final expression. And there is a time difference between these two kind of propagation, so that difference can be evaluated by T2 minus T1. And this is the final expression for time difference. Similarly, if we will rotate the whole Michelson-Morley's experiment by an angle of 90 degrees, then instead of simple times T1 and T2, here T1 prime and T2 prime expressions are used. And for perpendicular and parallel propagation, again what we have done is, again we have taken the time difference, and by using binomials expansion, this will be the final expression which is written in the end. Now, by substituting the general values of length L1, L2 and V by C, which are fixed ratios, and their time intervals, it was believed that there must be a period shift of 0.4. But in actual, this experiment was performed a number of times by Michelson and Morley in those times, even though this experiment was performed in summers, winters and springs, during all the seasons. Since then, no fringe shift was observed at that time, and this was the basic, or we can say the main contradiction of Michelson-Morley's experiment. In this slide, we can easily observe the typical interference pattern which was actually observed in Michelson and Morley's experiment.